As you may know, my team's role in Optica is to reach out to more than 600 Optica corporate members to discover what they need and what's to happen next, either in online discussions or face-to-face communications. As part of the preparations for the Optica Photonics Economics Forum in Malaga, I am constantly reaching out to many CEOs and CTOs to understand their strategy at a time of sensitive geopolitics. Most of those discussions remain private, but there are exceptions. Here is an example of an interview which explains the strategy of one of the world's most influential silicon photonics foundries. I'm talking, of course, about AMF. AMF is based in Singapore and is seen as a champion within the datacom telecom industry. In order to understand what they plan to do next for silicon photonics clients, I asked their CEO Jack to explain to us their focus on solving interconnects for short or long distances in data centers. From early days in India, he moved to Singapore to work with companies like National Semiconductors, Philips, FEI, and then SSMC, a joint venture between NXP and TSMC. When he started, there were no wafer fabs in Singapore. Today, there are more than 25. So when did he first hear the word photonics?
So 45 years ago, I'm doing my engineering project. So in those days, there was mechanical tachometer to measure the speed of it, right? Use a mechanical tachometer. Hold it, then the needle moves, then you know that is 100 RPM, 200 RPM, 400. So I developed an electronics tachometer as my industrial project. So it's a simple concept. That means take a wheel, make holes, and then put a LED light on one side, you put a photo detector on the other side. So every hole it moves, it picks up a photo detector to pick up a signal. Right? Of course, those days not fancy photo detector of silicon photonics which we are talking about. I'm talking about simple photodiode. That's what I use. And then of course you connect it to the 7400 series chips with a counter and in those days we had only 7-segment LED display. Put a 7-segment LED display. Again, you touch the motor and then it picks up the RPM by the volts of the pulses and then you count it and they say this is the RPM. Mm-hmm. That is where my first interaction, anything to do with sensing the light or the photodiode, so-called the photonics. Then have I heard of photonics before joining AMF? The answer is yes. But at the same time, at that time, my perception was there is enough technology can use in 3-5 semiconductors, and that should be good enough. Over a period of time, in the 2000s, early 2000s, when you start seeing the IoT coming into the market, suddenly you see the pressure of speed. Mm-hmm. Of course, it's triggered with microcontrollers, right? It went from 16-bit to 32-bit to 64-bit microcontrollers. That's the first triggering part in the IoT that required the enhancement of the speed. The second, of course, the data centers that came into the market in the 2010, 2011. That's the one which has started taking a look at silicon photonics. So I just have heard of it, but I'm not a silicon photonics guy. The focus was when I was in SSMC, doing the CMOS, producing 1 million wafers a year, and looking into the bigger picture of what's needed for the automotive industry, and those kind of functionalities more passionate in. So when I came across the silicon photonics opportunity here, I assessed on my first outlook, this is a good, AMF is a good lab to use IPs, which is very, very valuable to the industry. And we are in a unique position to address the silicon photonics needs of the future. My own personal interpretation, I'm not a market analyst. My interpretation is what silicon photonics is going through today in the industry. It's way back in the early 2000s IoT. Billion devices was like a big deal in those days, right? I worked on many projects on IoT from RFID to NFC to, even 2 gigahertz, 5 gigahertz, 10 gigahertz transmitter and receiver using the CMOS bipolar, CMOS process, DMOS process. in the automotive industry, in the network industry. It was all driven by IoT. And today, exactly the same thing is happening for silicon photonics. Let's say in 2022, your report says 66 million devices. It's going to go to a billion devices by 27 or 28. The billion will become 5 billion, 10 billion, 50 billion, like where the IoT market is today, crossing that 50 billion devices. So the same thing can happen with silicon photonics because of the huge vertical market segments that exist.
10 years ago, if you wanted to have chips manufactured in silicon photonics, you could go to IMEC, you could go to CEA Leti, or you could go to A-Star. That was pretty much it. Others, VTT as well, and others were using E-beam, so it was not really that scalable. There were very few places where you could get silicon photonics manufactured. I'm talking 10 years, maybe 12 years ago, 2012, 2010. And right now, the ecosystem has changed completely. Right now, if you want to get silicon photonics manufacturing, you can get them from the above mentioned, but you can also get them from semiconductor fabs. And the future seems to be that the TSMCs and the global are going to be investing even heavier on the silicon photonics. So my question to you is, how do you see AMF's role in the competitive landscape of silicon photonics in the future?
Very good question. AMF is working on silicon photonics not after I joined. They're working way back in 2006. They started designing the IP, modulators, photodiode arrays, beam splitters, phase shifters, one IP by one. So that is, you come out with a concept, you design it and make it into silicon, verify the functionality of the device, and you characterize them. Subsequently, in the last 5 years, we have translated that to the PDK, like our process development kit, that we can give it to a customer so that he can make his DR4 product or an FR4 or a DR8 or an FR8 radar or a ZR. So that's the level of experience and the knowledge we have built over the last 20 years, or at least I should say 18 years to be exact. Now the question comes is, we started first for the telecom industry. Yes. It's not that we went, oh, we are intelligent enough to go to the telecom industry. Every telecom company came to us and said, can you do something on silicon photonics? I need a communication network. I need to take it from this town to the next town. The cable need to go underneath the sea. It is at a distance of 500 kilometers. I need a transmitter receiver that can carry the so-called my telecom signal and it should connect to the other. So that's where we start using all the concepts of coherent technology and develop those knowledge, and process, and make the silicon and give it to telecom companies. That's why today we supply to the telecom companies of the world, from North America to Japan to Canada to Europe. We are the number one player in that market. So that is the foundation for AMF as a silicon photonics company. So then suddenly demand started, the customers started requesting, hey, can you manufacture it? So that is where the opportunity came. A-Star, who was the research company under the Ministry of Trade and Industry in Singapore, decided, okay, we will make it into a separate company. Instead of just doing the research in the lab, they formed this company called Advanced Micro Foundries. And the company was started in the end of 2017. After 2018, 19, 20, I came into the company during the COVID in 2021. That's where the journey started. Of course, already I gave you the examples of our play in the telecom market. So then we looked at our portfolio, the next comfortable bet or the next comfortable fit in the market today is the intra-data center. That means if I'm in your town, let's say in Amsterdam, assuming that I put 3 different data centers for whoever in Facebook, Google, Amazon, everybody, right? or even for the telecom companies, it's a orange, right? When they have the different data center, you need to replicate the data, right? For the blockchain requirements, or you want to update your picture, or no, in the real time, right? So that is where the data need to be transmitted and received within the intra data center. My own data center, but it is at a distance of 80 kilometers, or it is at a distance of 50 kilometers. So that is the second entry point for AMF. So today we are a biggest player supplying the silicon photonics wafers to the ZR market.
Mm-hmm.
So by then, we started looking at the EML, the existing legacy 3.5 technology is reaching a stage of 100, 200. They can also push to 400, 800, they say, but they started seeing the constraint, the existing EML process technology, yield, IP, power consumption, speed. That is where the transformations has started happening in the industry from EML to IMDT, or today's photonics transceivers. We started making TR4. So that replacement part has created a big opportunity for us. So today, as AMF, we have our own process development kit that we have released for 400 gigawatt data transmission receiver. So our customers today, they just have to, they can design a product in 3 months. They just have to send the GDS file to us. Within less than 3 months, we give them the silicon. They can go and win the sockets in the market. Come back in the next 3 months, we can start manufacturing this in silicon photonics transceiver products for data centers.
We are right now, in my opinion, on this technology, we are facing the biggest challenge in the history. So we have survived, I don't know how, but we have survived a telecom bubble burst 24 years ago. And right now we are facing something called AI, which everybody seems to be talking about. Everybody seems to have a different understanding of the challenge that it comes. But as of today, when it comes to the GPU interconnect in a computer, we don't have silicon photonics yet. And there is when we are seeing that the major players like NVIDIA are heavily investing on silicon photonics after the acquisition of Mellanox. And we are seeing also that the current processors by AMD, by NVIDIA, by Intel do not have photonics in it. What are we doing wrong here? Is that something that are there difficult challenges for us to overcome? Is that something that the companies want to do themselves? Are we facing like a space race again for silicon photonics and somebody want to be the first one to do it? Or are we just too impatient and it will happen eventually?
I'm not, as I said, I'm not an expert of silicon photonics end market, but I want to say today, AMF is supplying the silicon photonics receiver products that goes to AI, ML industry. Okay. Now, I will, based on my strong background of semiconductors, I will divide this AI, ML market. You gave me an opportunity to come and participate in the OFC C-level executive summit, right? Mm-hmm. And when I spoke, I think the whole audience accepted. Many of them, they came, they had a discussion with me. It created business opportunities. I will not deny that. I can't say it is exactly on the AIML, but definitely it created business opportunities for us. It will create business opportunities in the AIML. I come back to the fundamental of my interpretation based on semiconductors, this AIML and GPUs. One is it's the what I call as the GPU to GPU communication. That requires, so high bandwidth modules, interfaces to the memory. It need to talk to and transmit and receive. And at the same time, if I have a GPU board, I come from the telecom board, right? I designed the digital switch. Concept is still the same. I need to communicate from one GPU board to the next GPU board in my data center. So the current existing connectivity is based on copper wire and the existing whatever you call it as TCP/IP or the IEEE or the standards that started that connectivity that cannot handle the speed at which the transceiver function happens. So today, the second market, in addition to GPU inside the board, in GPU to memory, memory to GPU that requires silicon photonics, the second opportunity that has came up is how do I communicate between board to board within a AI ML data center? So that is this second opportunity that has come into the market. It requires silicon photonics. The third one is even opportunities like can you design a switch using silicon photonics? I mean, I can use my silicon photonics array, like a olden days, I have done the PLDs, programmable logic devices, right? In using bipolar. Similar concept can be implemented in silicon photonics using an array of phase shifters and beam splitters, and then can come out with the digital switch that is needed for the servers of the data center. So it's another third concept. The fourth concept is, in addition, now with the AI ML servers coming and they're getting mixed into the existing data center, there is a kind of a crossover that will happen between AI ML and conventional data center. They get overlap. That is the one which is going to drive the need of silicon photonics. Of course, if you ask me, is AMF into that? The answer is yes. I told you we are the champions of the telecom industry. From that coherent concept, we came with the ZR, which is very successful. And from that concept, we know exactly what IPs and stuff you need for the data centers, 400 gig, 800 gig. We're already working on it. And then we have released the PDK so that the customers can use. And the next stage we are working on is you do the chip-to-chip communication. How do you transmit the data at a distance of less than 10 centimeters, 5 centimeters, or 15 centimeters within the board? So that is, we move from the 200 kilometers to 80 kilometers, which is here I explained, to the data center, which is less than 2 kilometers. We are coming into that.
The shorter the distance, the higher is the volume of production, always, right? So for us, is it more interesting to try to solve the problems on the shorter distance or to keep the momentum a longer distance?
On the shorter distance, the natural business lead, I call it, right? Oh, I get big volumes. But you need to ensure for a product that you do, it has fundamentally a strong IP that can make a product design successful. Step number one. Step number two is, can you do a shorter time to market so that I can take my samples and go and give it to hyperscalers, get them to website. Number three is, can you consistently manufacture month after month, year after year, day after day with a known cycle time, with a good quality system, the check and balance in terms of the so-called inline, offline measurements, electrical testing, optical testing, and outgoing quality control. And you need to know how to manage silicon photonics. It's a different animal compared to the CMOS or the bipolar or the DRAMs or the other things that exist.
This opens two questions for me, and I think they are very important on the strategy of AMF. So the first one is we are seeing right now from some foundries that they want to be vertically integrated and they want to do everything themselves. They want to be a foundry, and they want to be an OSAT, and they want to test their chips. They want to do everything to make sure that when the customer comes, he comes to a what they call one-stop shop. I never really loved that concept, but it's used a lot, one-stop shop. While others, they say, no, we want to be a pure play foundry, and we want to make sure that the customer comes with a GDS file and gets out a chip that has the design rules so he can package it at the Fix in the Netherlands, or at Fabrinet in Thailand, or in any other OSAT in the world. What's your strategy here? Do you want to be a one-stop shop for silicon photonics, or you want to be a pure play foundry and rely on partnerships?
It's a very good question. I will first answer for the one-stop shop. There is no scale of economy. It does not make sense for anybody. I'll be a one-stop shop where I do a product design, I will give you a PDK, I will do a wafer, silicon photonics wafer, I will do a co-optical packaging, and then I will do the electrical test and optical test. I will give you a pluggable module with all the 150 components in it. I will provide you the fiber optics cable, and then you do it. Okay. First of all, there is no scale of economy. Scale of economy is like the memory, like the microcontrollers, like the engine control module. So there is no such scale of economy. So that is one point we need to keep in mind. However, you need to have the wider knowledge of the entire food chain of silicon photonics. So what is the food chain of silicon photonics? It is the IP which we discussed, each modulator, attenuator, the grating coupler, everything. That is very, very critical. Low loss waveguides, silicon nitride, structures, slabs. So you need multiple IPs. That is the starting of the food chain. Next is this food chain. Are you able to do a prototype that you can give it to the customer? Of course, before that, are you able to give them a PDK, a verified silicon in real silicon, and also a reliability data that is behind it, so that the customer can use the IP and design a product, and you will give him a shortest time to market, can take this prototype sample, go to the market, win the socket. Then in the food chain is making of the wafer consistently, which we discussed already. And subsequently, are you able to test them? See, you can't expect a designer or the end user to verify whether it is the process is correct, whether the electrical PCM parameters are correct, whether the optical parameters are correct. And can you please ink off it? That is where the food chain I would encourage. If you want to do silicon photonics, you better do an electrical optical test. You ink off the bad guys. You give them a known good die. So
that must have been your biggest shock, right? When you came from TSMC and NXP and you arrived on silicon photonics and you realize how immature the DRC check or the validation of your design for the foundry is done. We are not there. We don't have the right caliber tools. We don't really have all the. How do you address that huge challenge, taking into account that you already came from an industry that had solved it completely?
Absolutely. For me, it's a norm, right? The inline offline measurement is a norm. Defectivity is a norm. Reliability of ELFR fits, whatever here we call it as waveguide loss or dark current, it's a norm. The industry in silicon photonics, they never practice that. Even though they say, oh, we learn everything from CMOS, we are CMOS compatible with. Yes, it's all statements. But are you practicing in reality on a monthly basis, quarterly basis, yearly basis? Are you verifying your silicon to the reliability standards of whatever you can call 883 specs or the Telecardia 9000 specs? Are you doing it? So, by the way, AMF is a Telecardia 9000 certified company. We follow the telecom industry standards so that they can confidently buy our silicon and use it in the applications so they get the known standards of the industry. So that was my first challenge. Okay. So I looked at it and then said, okay, we're going to first I set a direction to the company. We want to be our vision is we want to be a de facto in photonics. De facto means I want everybody who want a connectivity, computing, or sensing in the world, they come and ask AMF, I want to do this, do you have any solution? Have I reached that? The answer is no today, but that is my vision. That is a silver line in the cloud. I want to touch one of these. To do that, I told my colleagues, You need to practice every day what we call as the mission statement. What is that mission statement? I want to be an innovator. AMF, I want to be, as AMF, I want to be an innovator. I want to be a manufacturer, silicon photonics, so that I follow a discipline of what I call as the SQDCP: safety, quality, delivery, customer. It is done by our people. I care for them. At the end of the day, the sustained profit. Any organization, you don't make profitability, all the stakeholders will come after you. Right, Jose? I mean, I'm sure you have seen that in the past. You are seeing it in the Optica also. Because you got to make sure, the money comes in to the money spent and there is a proper justification and you have enough buffer to do the next project and so on and so forth. So that is the mission statement. So as a mission statement, we are an innovator and a manufacturer. We are going for sustained profitability. I follow the discipline of safety, quality, delivery, customers, and my opinion.
If
Statements.
if we had this interview in 5 years, let's say 5 years, what is your preferred future? What do you think AMF and the silicon photonics industry is going to look like in 5 years? Your preferred future, not it doesn't have to be right or wrong. It's just your wish.
My wish for the preferred future is we have already established in a couple of vertical market segments that I explained to you on the telecom, the ZR, the DR. By the way, we are the big player in the LiDAR also. We do more knowledge of. We do the FMCW LiDAR, frequency multiplexed continuous wave. Yeah. So we make that LiDAR products, and we have done for many customers of the world. But the market acceptance has to come. You start using it in industrial LiDARs or even automotive LiDARs. Right? So in that direction, by the way, we're also doing some sensing for medical application. We do the analysis of the so-called hematology or whatever the samples you are doing. By the way, we are doing AR, VR mission. By the way, we are doing it on a glass substrate. So there's a fundamental R&D that is done for many of the vertical market segments. 5 years down the road, I want all these market segments are willing to move towards the silicon photonics from the conventional 3.5, the conventional legacy EML, legacy VCSEL, towards IMDD, and towards the silicon photonics, towards the FMCW, towards the visible light range. Then it creates enough base on the volume.
Mm-hmm. I think here it's unstoppable the fact that new materials are going to have to come, correct?
We're working on all the possible new materials we can think of.
And this is what I wanted to ask you. Strategic-wise, what are the partnerships that you are setting up? You kind of mentioned the partners, at least the scope. And what is your preferred future toward working together in the future with other partners?
We are already working with many selected partners today, which we don't disclose. Or only when the time comes, you'll see some press release here and there. Well, there is AMF together with first we will launch it, and then you'll see AMF together with. So we'll disclose on a timely basis. So our business model is very simple. Other than silicon photonics, the direction of the company, we're not going to do anything else. Number two, we're not going to make a product that I compete with my own customers. The business model is I will be a foundry forever. I may have all the knowledge to make a silicon photonics product. We'll help our customers to improve their design and process and testing so that the product will come out successfully. But we're not going to make a product.
Another thing that I wanted to ask you, that's 100% the foundry model. Is make sure your customers succeed and make sure they keep their IP. This is the ABC of a pure play foundry. I want to ask you a controversial question. Feel free not to answer if you don't want to. But right now, you come from the semiconductor industry, from TSMC and from NXP. You are used to ultra high volume production and you're used to fabs that produce hundreds of thousands of wafers. A lot of people are talking to the photonic industry about sustainability of the production. They are talking to us about PFOS and PFAS emission. They are talking to us about controlling the kind of materials that we are using. In your opinion, is this realistic, taking into account, if we put in the big picture, how sustainable other productions are compared to photonics? Still is a medium to small size market. Do you think we should be worried today about sustainability, or do you believe that this is a political development that should be more focused on the ultra large foundries developing 1 million wafers a year?
Today, anybody can make silicon photonics. They need to spend, like a team of 20 PhDs, spend the next 5 years with the $200 billion, then go after the customers, make customers who spend the next $1 billion, then you can get into the market. So the existing players of the CMOS, the semiconductors, they're not going to come in to a market size of 1 billion devices. They are only used to the 100 billion or the trillion devices. That is the scale of economy, right? So it is the existing market of 1 billion devices by 2027 or 2028 is not attractive for them to come into the market. And also, there's the big entry barrier, which you discussed, right from the IP all the way to PDK to setting up a dedicated prototype labs and setting up the dedicated manufacturing fab, plus the knowledge of all the things we discussed, from quality programs to reliability to authenticating the functionality of electrical optical test, and it requires bigger commitment. Right now, the challenge for the industry is the volume is not there. The entire world's silicon photonics volume, a company like T or a company like G or a company like anybody, they can start the wafers one day. They say, come back after 70 days, we'll give you all the wafers. That is the only size of the market. So that is the tougher part right now that exists between a successful company that can grow in silicon photonics, or whether they're able to survive through this scale of economic growth if it does not happen.
What is, in your opinion, right now, our biggest challenge for addressing the coming needs? I think we have maybe a workforce problem, we have a lack of standardization problem, and I also believe that we are very much into hypes. Suddenly, FMCW LiDAR is a big hype, then quantum computing is a big hype, then co-packaged optics sounds very strong, then now linear drive optics comes again really strong, and now it's all about AI. In your opinion, what is the biggest challenge for us as a Silicon Photonics community?
Today in the Silicon Photonics is the standardization. Everyone, including me, I want to do my own IP, my own process, my own little bit of tweak and turn, my own way of testing. It's not going to work. My own substrates. Can you give me a 300 nanometer box? Can you give me 220 nanometer box? Can you give me 4? But it's not a. So the mindset of the Silicon Photonics right now is still pretty much the R&D mindset.
Yeah.
So they have to accept the market standardization, accept the industry standardization, accept that there is a cost when there is no volume. Then they can get in successfully. So the first challenge is the standardization. The second challenge is the industry do not have the practice of semiconductors quality and reliability. The industry do not have the scale of economy of the semiconductors. It's all small volume, which we discussed, right? And it is difficult to make to make all this, and everything you want to customize. The moment you start everything you are customizing, there is no chance you can make money.
That is the biggest challenge, in my opinion, for silicon photonics. The fact that as a pure play foundry, you want to be.
What we are trying to do, let's admit to it. Of course, at the same way, we are not keeping quiet to give the challenge and then deal with it. The way we deal with is here is a standardization for you. Here is a silicon PDK that works. Here is a method of doing the electrical optical testing. Here is a method of making sure you do the AP process. No? Here is a method of making sure you get your supply on time. Here is a method of handling your supply chain. That is what we are offering today to the market.
I think it's been great. I would like to ask you now a question that I announced in the beginning. If we could start all over again, we go back to Indian telephone industries, 1979. What kind of things would you do differently, earlier, or not do at all?
If I can unwind the clock to the 45 years or 43 years. So what will I do to set? Definitely, I'll focus, first thing is on the foundry model that did not exist in those days in semiconductor supply. And second, I will go for standardization of the food chain, which we discussed. There was no standardization of the food chain. Even today in silicon photonics, there is no standardization of the food chain. That's what I'm trying to address as a leader in the industry. Not only the selfish needs of AMF, also the bigger needs of my customers and the silicon photonics industry. Standardization is second. Third, I will go and adopt the new technology that is available in it. Rather than I sit and keep on, see how much more I can milk from the existing technology. So today you have concepts of FMCW, today you have concepts of array of photodiodes, today you have the concepts of silicon nitride waveguides. I will use it. So that I will be, even though I'm a little bit more advanced to the market needs, I get ready with the technology that's available. So that's how I unwind. Of course, if I can unwind, I do it. The second thing is, if I was the leader at that time, I will build my team who have the knowledge of the silicon photonics and semiconductors, bring them all together, put them into activity that the business calls for, so that you are in a good position to deliver a best value to the customer, so that he can address his time to market and time to volume of the foundry business. Foundry business only started about 30, 35 years ago, even too long. I would say in the late 80s, foundry concept has started. Before that, it was not even existing. So, in that sense, I would say for today, for silicon photonics, companies like us and others in the market, we are confidently bringing in foundry business.
Jack, it has been a great interview. I feel really bad because I promised you that we'll finish like 39 minutes ago. So I am sorry about that, but it has been really great, really great. Thank you so much. All the best. Take care of each other. See you very soon. All the best. Thank you. Bye-bye. Bye. Thank you. Bye-bye.